So I said there was three ways we measure the amount of moisture in the air. One of them is vapor pressure, and the second one is relative humidity. And relative humidity has its problems. It's temperature dependent. Remember when we were figuring out relative humidity, you needed a dry and wet bulb thermometer. So as soon as the temperature changes, your relative humidity is going to change. This is really annoying as a meteorologist. Imagine a typical day, right? When the sun comes up, the temperature is going to come up. But since the temperature is going up, the relative humidity is going down. The lowest relative humidity of the day is the hottest time in the afternoon. And in the summertime, that's the biggest chance for thunderstorms. It doesn't make any sense. So relative humidity is really an annoying tool to use. Why it's still used on television, I don't know. If I was in charge, and someday I will be, we're going to get rid of relative humidity altogether with the public. And we're going to go with the third choice. What we really use for humidity is dew point. Dew point is a temperature, and it's the temperature at which the air becomes saturated. And we talked about saturation vapor pressure because here's where it comes into play. Here's that graph that we were talking about before. Let's do an example. Let's say we have 42 pieces of water in the air, giving us a vapor pressure of 42. Well, here's how we're going to use this graph. We're going to find 42 there on the y-axis, the vertical axis, and we're going to follow that over to the red saturation vapor pressure line. And where it intersects, we're then going to drop down and read the temperature there. So at 30 degrees Celsius or 86 degrees Fahrenheit, the air is saturated when the vapor pressure is at 42 millibars. Now again, the millibars should mean nothing. You could forget about that unit whatsoever. As the numbers get higher, there's more water in the air. As the numbers get lower, there's less water in the air. So let's say we have a dew point of 50 degrees Fahrenheit. A dew point of 50 degrees Fahrenheit, we follow that up to the red line and go over. It's telling us that there's about 12 millibars of water in the air. 12 pieces of water in the air. That's lower humidity. So look at the graph one more time. Notice as you get lower temperatures, you'll have less water in the air. Higher temperatures, more water vapor. That's how the dew point works. The higher the dew point is, the more water there is in the air. The closer the actual air temperature and the dew point is, the higher the relative humidity is. So we can use dew point to figure out how saturated the air is. Let's look at these two thermometers. Numbers don't matter whatsoever. You just have a big red line on the left for air temperature and not as big a line on the right for dew point. Here, they're far apart. The air temperature and the dew point are far apart, so we have dry, low relative humidity. As I increase moisture in the air, I'm going to increase that dew point. So we bring it up a little more. It's now closer to the air temperature number. The relative humidity is increasing. And if my dew point is exactly the same as the air temperature, the air is at saturation, and by definition, the relative humidity is then at 100%. The air is full of moisture at that point. So I hope you can see how this is a better way of describing the amount of moisture in the air. In other words, dew point is the temperature that the air gets to 100% relative humidity. The higher the dew point is, the higher the humidity. And the dew point can't be higher than the air temperature. If the dew point's higher than the air temperature, that means we'll have over 100% relative humidity. And we can't have that. In the summer, it's not the heat. It's not even the humidity. It's the dew point. When I'm on television, I use this image that you see there on the left. I call it the muggy meter. And the dew point tells us how muggy it's going to feel outside in the summertime. High dew points mean high relative humidities means moister air. And in the summer, that could be uncomfortable. So typically, a dew point in the 50s, it's going to feel comfortable. It's okay. In the 60s, it's muggy and it starts to get uncomfortable. A hot, humid summer day, we have dew points in the 70s. And every now and then you'll see a couple in the 80s. That's just downright horrible. This is a map of the average dew points as we go through the month of July. Lancaster is very close to 70 degrees. Our typical dew points are in the upper 60s. Notice where the most humid air is. It's around the Gulf of Mexico and in the southeast. That's because the Gulf of Mexico is trying to kill us. More on that later. And a dumb and useless fact for this video, the highest dew point ever measured in the United States was July 14th, 1995 in Appleton, Wisconsin, where they registered a dew point of 90 degrees Fahrenheit. So let's take a quick check. If you understand what I just said, you can answer this question. If the air temperature stays the same, as we evaporate water into the air, the dew point will what? And the relative humidity will what? Think about it. Your answer is D. If the air temperature stays the same as we evaporate water into the air, the dew point will increase. We're increasing the amount of water vapor in the air. The dew point goes up. And the relative humidity will also increase. The dew point and air temperature numbers get closer together, increasing the relative humidity. That's there in the answer. Dew point measures how much moisture is in the air. Evaporation puts more moisture in the air, dew point increases. As dew point increases, it gets closer to the temperature, so relative humidity increases as the gap gets smaller. So now look at this review question and go ahead and pause until you're ready to see the answer. See if you can figure this out. All right, remember that the higher the dew point, the more actual water and moisture there is in the air. The difference between those two temperatures tells you what the relative humidity is. So which city has the highest relative humidity? That's going to be B, because city B has a temperature of 10 degrees and a dew point of 10 degrees. There's no difference there, so it's at 100% relative humidity. The city with the most moisture in the air is city A, because it has the highest dew point. And the city with the least moisture in the air is city B, because it has the lowest dew point. City B has the least amount of water vapor in the air, yet its humidity is 100%. And that's possible because the temperature is very cold, and colder air has less moisture. Measuring the dew point is reliable for me as a weather forecaster, and that combined with the temperature can help me forecast the weather a lot easier.